welcome everybody to our September webinar. My name is Dave Hodgins. I have the pleasure of hosting these webinars each month. I'm really excited about this one. I'm going to keep my piece brief because we have a great roster of guest speakers today. We'll be circling back on some award-winning projects and seeing, where are they now and how do these projects have application today as we sit again in yet another worst fire season ever, and we see flooding in other parts of the country. So this is not a future thing anymore. It's really a way of life, as I think a lot of us on this call know. So with that, let's keep moving. Next, please, a couple of housekeeping items. And thank you, of course, as always, to our sponsors. Now in our 10th year as a program, I want to really thank LADWP and SoCalGas for their support of our educational programming and our other work that we do. Next, please. So housekeeping as usual, things will be muted. We're going to try to save time at the end for questions. Please do send them in as we go. We'll try to respond and save those for the end that we can. We will be sending out the slides. There's some great stuff in there, so don't feel the need to write everything down. We'll also be recording and sending that out all on Friday. We will also be dropping some stuff in the chat, some white papers and other interesting resources. So keep an eye on that and tell us how we did. Speak up, please, as we go, and that makes it more fun for us. So with that, I'll dive in just a few framing comments, and I'll get it over to my colleague Maureen, who's going to be hosting and introducing the rest of our speakers for today. So let's go ahead and move forward. Thank you. Next slide. Let's keep going. So here's a hypothesis. Drinking water should be for drinking. How about that? We don't think about it this way, but we're using drinking water to flush toilets and wash our hands a lot and cool our buildings and irrigate our lawns and our drought tolerant landscaping. Let's think about that. Look at where we are. We live in a desert, right? I think a lot of people are starting to realize, how much we rely on buildings to protect us as the weather becomes more extreme. And so we need to be smarter about this. And of course, you can go longer without food than you can without water. So kind of beating a dead horse here, but let's start from this premise as we go in today. Next, please. Like I said, this is not a future thing anymore. I read a few articles, actually an obituary, in fact, for the Great Salt Lake, and it was really sad. Utah has the lowest prices per gallon of water anywhere in the country, besides one other place, so I won't say who's the worst. But basically abused this resource, did not really think down the road, and now it's going to affect all of us because there's an unintended, or at least something I hadn't thought about. Utah's soil is full of arsenic, right? So when this thing dries up, what's going to happen? That's going to blow all over the place. Shit, I hadn't thought of that. So these are the other ways that drought comes home. So again, drinking water for drinking. Next, please. So, if you could save 1 million gallons of water, would you? Yeah. And the guys that we're going to hear from today can do this. An average tower that we look at, cooling tower, and we're going to focus on cooling towers today. This is very possible. This is very, very possible. And we're going to talk about some ways to get at that, some real examples and on-ramps for that, great new incentives. You're also saving energy, of course, if you're saving water. We pump our water hundreds of miles, and this is not a very tenable arrangement, right? Going forward, there will be an earthquake too. So we need, again, to be thinking about local water. That's part of the sustainable city plan that's been in the plan for 5-6 years now. Cedars-Sinai, probably the biggest project contributing towards that goal. We'll hear from today how that's going. And we are really excited to support anyone that's interested in learning from that, trying to replicate it at your site. So more local water, reducing our reliance on foreign water, right? Imported water, also a good idea from an energy perspective. So I think that's my last slide. And then I'd like to introduce my colleague. With that, thank you for everybody for joining, and over to Mo.
Hi, Jay. Thanks so much for the introduction. And yes, just want to give a little bit more context on our local conditions. So yes, we are in a drought. 94% of California's in an extreme drought, with 46% in an exceptional drought. That's the highest level that there is. And drought is just becoming more common for us in the West. Over the last 2 decades, there have been 3 dry years for every 1 wet year. Next slide. Here in LA, this is compounded by the fact that 85% of our water is imported from 3 different sources. The Upper Sierras through the State Water Project, the Lower Sierras through the LA Aqueduct, and the Lower Colorado River Basin through the Colorado River Aqueduct. And although last year was critically dry, the snowpack in at least 2 of those sources wasn't that bad, 72% in the State Water Project and 88% in Colorado River. But however, due to severe dryness, the hottest spring on record, most of the water evaporated and didn't run off to fill in our lakes and reservoirs that we could use for our drinking water. And this really came as a surprise to the state water planners, and they've been analyzing it and figuring out how to better plan for future years. And they believe it may be aridification, and our semi-arid region is becoming more arid. We do, as Dave said, live in a desert. The outlook for the coming year is looking bleak. They're anticipating a 0% allocation from the State Water Project for Southern California. And in August, a shortage was declared on the Colorado River, the first time ever since the Hoover Dam was built in the 1930s. And the latest studies are showing a continued decline in reservoir levels. Next slide. And although the governor has called for a 14% voluntary reduction, it's been hotter and drier weather. So as could be expected, LA's use has actually gone up. LA's per capita use has gone up 8% since a low in 2019 of 105 gallons per capita per day. It's now up at 113. Our goal is to be at 103 by 2025, or the mayor's goal, part of the sustainability plan. And we're headed in the wrong direction. Next slide. To add to that, the water's undervalued. We basically pay for the infrastructure to bring the water to us, not the water itself. And this is by design because we want to ensure that all Americans have access to clean water. But this is changing. Water prices are expected to increase 5% per year over the next decade, which is nearly doubling. Maybe, who knows, will it be as expensive as electricity in the next 20 years? It's possible. But right now, the affordability of water makes the ROI on many projects unattractive. But there's good news. Cooling tower efficiency upgrades represent a huge opportunity for water savings. And there are over 5,000 cooling towers in the city using over 6 billion gallons of water each year. And these systems can be cost effectively upgraded with improved control, monitoring, and upgraded water treatment, which you're going to hear about a couple technologies and projects today. And for some who have available non-potable water sources, such as recycled water or nuisance groundwater, there may be an opportunity to offset water use. And as we said today, we're going to learn more about some of these innovative projects and technologies. And even more good news, we're going to learn about LADWP's new programs. They've nearly doubled their incentive and are now offering free assessments of cooling towers. Next slide. So today we have 4 fantastic speakers, starting with Sean Collins. Sean is the Executive Director of Facilities Planning, Design, and Construction at Cedars-Sinai, and he's responsible for the design, development, and management of capital projects at Cedars. The department leads Cedars' strategic growth and capital development at the Medical Center, the Marina del Rey Hospital, and all of its growing affiliates. Sean and his team implement some really innovative projects focusing on delivering high-value healthcare in a high quality environment. And today, Sean is going to bring us today up on an awesome project they implemented a few years back, where they're reusing their nuisance groundwater, and the project is saving over 20 million gallons per year, up to 28 million gallons a year, really one of the largest in the city, and for which they received the 2018 Innovation Awards, Water Efficiency Project of the Year. We also have two speakers from Dynamic Water Technologies, Mike Boyko, who Chief Operating Officer and founder of Dynamic Water Technologies. Mike has been working with water treatment systems and pollution control technologies for almost 30 years. He's extremely knowledgeable about the water needs and water quality in the Southwest. And I've worked with Mike on several projects, and he and his team are truly committed to helping customers significantly reduce water use and potentially eliminate chemicals. Their technology, which uses electrolysis for water treatment, is really elegant, and although may seem complex when they talk about reactors and splitting hydrogen and oxygen, it's really basic chemistry and is producing amazing results. Mike is joined by Dr. Janco Vermeulen, and he's a mechanical engineer at Dynamic Water. And Janco is from South Africa and is an expert in electrochemical water treatment. His expertise and postdoctoral engineering degrees focused on a combination of energy and water optimization for industrial sectors. Mike and Janco are going to give us a brief overview of the dynamic water technology and their method for achieving dramatic water savings. They'll also highlight a couple case studies, including an installation here at LA City Hall East, where they've seen nearly a 20% water savings, resulting in over 4 million gallons saved per year. And last but not least is Ben Slick, a senior vice president of business development at Hydropoint. Ben has been working for 40 years in the software and network services industries. And at Hydropoint, Ben is responsible for business development, strategic partner relations, and key customer accounts. I've worked with Ben for over a decade, and we've worked on numerous projects together. And through Hydropoint's smart irrigation solutions, WeatherTrack, customers have seen reductions in 20 to 30%. Today, Ben is going to talk about some of their newer technologies, Water Compass, which is a flow monitoring and leak detection technology. And it's not just flow monitoring and leak detection, but data and analytics that they're using to gain a deeper understanding of water use and allow for better management of water use. And now I'll turn it over to Sean.
All right. Well, thank you, Mo. Appreciate that. And I'm going to kick it off here, and you can advance to the next slide. And I'll say that what we're talking about here, at least for the project that we've implemented at Cedars-Sinai, it is not a cooling tower project, but it actually leverages water for our cooling towers. And you could go to the next slide. And then I'll just start off with the project itself and talk about the benefits of what we've done. But to give you some context at Cedars-Sinai, and I'm sure many of you are aware of our main campus in the center of Los Angeles, bordering both West Hollywood as well as Beverly Hills. In the city of LA and in our location, it actually is a beneficial location because of the high groundwater table. Our campus has over 13 buildings, 6 million square feet, and we happen to go down a few levels, so much so that we're actually into the groundwater. And because of that, we have a series of sump pumps throughout our buildings and campus that on average, at least 2006 to 2015, we were pumping out and literally dumping 80,000 to 120,000 gallons a day. And that was being discharged into the storm drain at the time, which means it literally was going out into Santa Monica Bay, going down the Ballona Creek and then just out into the water there and not being leveraged. And so during that time and working with both LADWP and evaluating this and looking at measurement of all the groundwater that we were using, on top of, there was a strategy put into place that the city wanted to start to use water, and they wanted much of the water and or wastewater to go into the sewer system because that could be recycled ultimately. And so we worked with Rethink H2O, and we implemented a groundwater utilization project. And because we're a hospital, and this is implemented within our main central plant to support the hospital as well as the other buildings, we actually had to go through our state entity, which is the Office of Statewide Health Planning and Development, which took a little bit of time. But we designed it, looked at, put it into place, and then we got the project going into 2018 overall. And so the idea behind this is that through a series of pumps and piping that connect to our sump system, we then put those into a series of holding tanks, buffer tanks, and filter system, and then leverage that and then pump it up to our cooling towers. And through that, we typically leverage between 80 to 90% of what we're pumping out of sort of this underground river or the groundwater system. And we pump typically about 80 to 90% of that up to our cooling towers. You can go up to the next slide. And so with that, I just want to talk a little bit about, our evaluation with this. The project overall was about, I think it ended up costing, the project itself was about $1.7 million. Now we have scale here. I talked about that 6 million square feet and the number of gallons we were pumping out there. But we also looked at it in terms of incentives. So offsetting this cost, we had fines for dumping into the stormwater. We had incentives, both from LADWP as well as the Metropolitan Water District, much of which Mo actually helped us get. And then another benefit we looked at, and this is in an extreme scenario, is that because of the holding tanks and given that we would continue pumping throughout this process, is that in the event of a disaster, there is the potential to actually leverage this as a potable water source and use that for our patients and our campus during a disaster. On top of that, working closely with the City of Los Angeles, their sustainability department, the mayor, if many of you may be aware, as part of his sustainability goals and looking at the city was to reduce water use by nearly 100 million gallons a year. And you saw Mo go over that data with some of her slides previously. And what I'm about to show you is that we're accounting for nearly a quarter of that. So our footprint, 6 million square feet, center of Los Angeles, we have met nearly a quarter of that goal. We're seeing nearly $200,000 a year in terms of savings, and that includes maintenance for the system, which is replacement of filters and things of that nature. So you can see that very quickly that the payback period for a system of this scale is pretty quick, and we're actually close to paying for that. You can go to the next slide. And then looking at some of the data here, you can see on the left in March 2017, and when the system was activated in May 2017, immediately there was a drop as to our overall consumption. And then there's a spike that goes into March 2019. That actual spike is sort of a learning process because for this groundwater system, and you can see on your right, the series of filters and everything, and Mayor Garcetti, who we had the pleasure of hosting and touring this facility here, we had a little learning curve. We didn't replace the filters appropriately and or bypass certain things. And so we were clogged, and we ended up actually dumping more water than we needed to, and we very quickly corrected that. You can go to the next slide as well. And then interestingly enough here, and you can see that recently, even though ironically we have been in a drought here, our groundwater and reclaimed water has actually increased over time. And so in 2019, 2020, I think we were at 22 million gallons in 1925 million, I think in 2020. And this year we're projected to be near 27 million gallons that we're leveraging and using for processed water. So reclaiming that and using it. So the efficiency overall here is not just that we're using a resource beneath us and not just dumping it out needlessly, but we've also diverted it to the sewer system so that it actually could get recycled at the end point as well. You can go to the next slide. And this is what we're seeing overall. is, aside from the incentives and the savings and the pay and the quick payback, is we're looking at, 21, 27 million gallons a year that, is being used. We've reduced our overall water use on our main campus from 15 to nearly 20% overall. And that is just phenomenal. One interesting aspect here is I'm sitting in a building on Wilshire right now, and we've been contemplating installing the same system here and leveraging it for processed water for our cooling towers. But interestingly enough, as we did the same thing, and you'll get the next speakers, you'll hear about measurement verification and the importance of installing sensors and things of that nature, is we have been measuring the use. But ironically is because of the metro rail construction, all of a sudden the amount that was going out of our sumps reduced dramatically because they have been pumping it out as they're building the new metro rail along Wilshire. We actually worked with LABBC and evaluated a number of different addresses down the line, and sure enough, the amount that they were dumping went down significantly because of the metro rail construction. And so that's something we're going to continue to evaluate here in our Wilshire building as well, and whether or not we can implement that. But I think, given the savings that we saw here, knowing the water issues that face us overall in terms of this drought and the importance of having potable water, especially during disasters, this has become an important piece and strategy for us overall, because we know it's not just about savings, it is about the environment. And I think to that point, Cedars-Sinai, we are a health system, we are a hospital. We see sustainability as really being, holistically intertwined with healthcare. The disasters and or climate related tragedies that David mentioned overall, those disproportionately affect members of our society and or areas who also happen to see high levels of chronic diseases, which in turn are something that we have to treat in terms of healthcare. So our strategy right now is how we can treat people, how we can look at chronic diseases is also tied to our diversity, inclusion, but also about sustainability and healthcare. And so we're making a commitment in terms of bringing on higher sustainable and or high performance buildings. And we continue to do that. We're actually going to replace 3 additional cooling towers on our main hospital. And additionally, LABBC has been such an extraordinary partner, and as well as LADWP and SoCalGas and others. Our commitment is to continue to deliver not just high quality care, but high performance buildings, because we know that it's going to help the environment, and it's going to help society, and it's going to help our community.
Thanks, Sean. That's super interesting. I'd like to hear more about your return on investment and what you're looking at the hospital, as well as what you think it potentially will be at the Wilshire building as well.
So, I don't think we're going to see as substantial a savings. I think the amount of gallons that we're pumping out here, at least, historically, wasn't nearly what it was there. And that just has to do with footprint. However, I think that given, the things that you've talked about, and I think that we mentioned or that we were talking earlier on our session, is that, the pricing of water is cheap right now. That doesn't mean it's going to remain the same, especially with the things that we're faced with. And so I think both preemptively and as well as, we like to say we like to do the right thing. This is just something we have to do, which is that leverage it for a higher use and not just, use drinking water for things that, are needless. We should use things that are other resources and recycle water as best as we can so that we can give back.
Great. Thanks, Sean. And now we're going to hear from Mike and Janco from Dynamic Water.
All right. So hopefully everybody can hear us okay. Thank you for giving us some time today. We both Janco and myself have been really building this company, this technology from the ground up. We brought this in from the Middle East and have optimized this process technology over the past 6 years and have really started rolling it out in a lot of different places across this country and across Africa. So you can go to the next slide, please. The basic challenges with cooling tower systems are typically scale, corrosion, and biocontamination. And basically, this is integral to the process of HVAC and cooling in general. So we deal with both commercial, industrial, and large manufacturing processes, mine sites, et cetera, all with the same type of scale challenges. Next slide, please. So what we're doing a little bit differently, instead of using traditional chemical treatment, we're actually using what we call our dynamic scale reactors, or DSRs. These DSRs are using a partial electrolysis to basically pull scale into our reactors where we can control it. We're mitigating corrosion by keeping a more concentrated calcium process inside the process water itself, and we're generating the active biocide, chlorine and hypochlorous acid from the water itself using that partial electrolysis. The unit shown here is actually one on one of our SoCal gas installations. And again, it's like a kidney system, as Janco describes it. Basically, we're taking process water from the basin itself into our reactor, back into the basin. So the implementation of these technologies is very, very simple and very easy to implement. Next slide, please. The benefits of this technology are quite substantial. We typically save somewhere between 15 and 45% of the makeup water in a given process. Sorry, the timing may be on this slide. Can you go back one slide, please? We're saving about 60 to 90% of the sewer savings, reducing any kind of scale on the tube's heat transfer surfaces, eliminating chemical treatment. And and the typical return on investment is between 1 to 4 years. We've been averaging about 2 to 2.5 years. Now, next slide. Again, like I mentioned, we're using partial electrolysis, and this partial electrolysis allows us to actually use low voltage DC current on the anode itself, putting basically a pH gradient into the cathodic surface, the cathode reactor. This environment allows two things to happen. One, the generation of chlorine and hypochlorous acid allows us to actively sanitize the water, and then the high pH on the wall of the cathode is allowing us to pull unstable calcium, magnesium, and scale forming mineralization. It allows for a much more cohesive and complete treatment of the process water. Next slide. In this slide, you can see some of the calcium and magnesium, and this is from drinking water. We're pulling these minerals that would form scale inside the reactors or inside process water systems, your heat exchangers, your cooling towers, your process piping, and we're putting it in a place where we can service it and when we can actually maintain this. The benefit of this, again, is quite remarkable because the heat transfer surfaces are optimized. The water sanitization is much more effective, and this has been proven time and time again than traditional chemical water treatment. It's just a better system. It's better, faster, and cheaper than traditional process. Next slide. We've been vetted a number of times by third-party analysis and review. The first one was through the U.S. General Services Administration, what they call their High Impact Technology Program, through the Green Proving Ground. And that was at the Federal Building in Savannah, Georgia. The other one that I actually brought and worked with Enroll on the City Hall East project was also validated independently, and both of these are published studies. The links below, you can actually go to either of those sites and read the complete studies. They're quite detailed. Next slide. The first review that was achieved from the GSA on the federal building in Savannah, Georgia, was a net water savings or reduction of about 32% in overall makeup water. A reduction in their overall maintenance because they actually had no chemical treatment to do whatsoever. They had a lot less biologic buildup because we actually are sanitizing the water at a much more effective rate. 100% elimination of their chemicals and a calculated payback of 2.5 years. Next slide. And their determination was actually the consideration and implementation of this technology in all cooling towers, especially in areas where water costs are high or water hardness and mineralization is high. So in fact, we're working with the GSA and the federal groups next week on a rollout plan for a number of federal buildings. Next slide. And of course, Los Angeles City Hall, I think everybody's familiar with it. The City Hall East building is actually their primary offices and data center. We worked extensively with the City Hall management and engineering staff. We brought in the National Renewable Energies Laboratories, and they did an independent validation study. That system has 4 750-ton towers. We have 2 skids treating the system in there. And it's not only doing a better job at scale control, as you can see in the images here on image 1, 2, and 3. Image 1 is right before we started, and that was a borescope image inside their chiller, which is their heat exchange surface. The second image is actually 3 months later. Bill Brady, the chief engineer at LA City Hall, borescoped it, and his jaw was on the ground. He said, well, where did my scale go? I said, Bill, over time, we actually removed scale from heat transfer surfaces. And he borescoped it 6 months after that. And every 6 months, we've been borescoping the chiller tubes, and they've been spotless, immaculate. So we've achieved theoretical perfection on the heat transfer surfaces, which chemicals just frankly can't do. In addition to this improved overall treatment for scale formation, they also have done an extensive biologic study using dip slides. And we didn't know this. We were doing dip slides anyway, but they compared us against their entire portfolio in the city of Los Angeles and came back to us and shared with us that our treatment is far more effective than any other chemical water treatment system that they have in their portfolio. So we're not only doing a great job, we're doing it better than they had previously done it with chemicals. What's also fantastic about this process is we went from 3 cycles of concentration to actually in excess of 10. The calculated measured savings was about 19% in their makeup water and a 76% reduction in sewer discharge. We've subsequent to this study here, we've actually got up to 24% overall savings year over year. Next slide, please. NREL again was very diligent in how they actually measured everything. So this is all in the published report. The proven and measured savings of 19% was documented. And again, we're continuing to measure and monitor this. And as was mentioned earlier on, measurement is really critical to understanding and valuing the water and other related benefits to the technologies that we want to implement. Next slide, please. This is another facility, one here in Arizona. We also have very inexpensive water and sewer in Arizona, surprisingly, even though we are a desert. This system is on another data center, actually, 3 800-ton towers. This system, again, was actually in pretty good shape. We've improved the overall performance, so we took their biologic levels down. We changed from about 2.2 cycles of concentration to 6.12. As you can see here, the blowdown set point is actually your conductivity set point. 3,000 microsiemens for Arizona is actually not significantly high. It's pretty typical. We moved it to over 7,000. The measured savings was 35% overall water and 77% reduction in blowdown. Next slide. We were very diligent. We had a third-party evaluation group also measure this. We had stated and promised 3.2 million gallons of water saved. We actually delivered 4.2 million gallons year over year and have been consistently providing that over the last 4 years. Next slide, please. And so again, the technology in general, and I like to talk about our process, the idea of this technology is you have to have a system that is not only functional, but actually provides a measured benefit. And so we love to go head to head versus chemicals or other treatment methodology. And we're very proud that we continually work to improve our process year over year. I'll actually wrap it up there. I'm about 9.5 minutes, and I try to keep it right in the 10 minutes or under there.
Thanks, Mike. Excellent job and fantastic presentation.
Thank you.
I'm just going to turn it straight over to Ben from Hydropoint.
Sure.
Hello, everybody. I'll dovetail into some of the dynamic water success stories. And our technology, Water Compass, is a flow monitoring and leak detection service, but moreover, it provides real-time data analytics and information that people need to make decisions about how to manage water. And the way we're used in cooling towers can be a very effective way of baselining and then doing comparative norming that would dovetail right into the kind of stats that Mike was showing earlier. Our first product was WeatherTrack, and I've worked with LABBC and Maureen for a decade and a half, driving water use efficiency solutions by reducing waste on landscapes. that same customer set came back to us and said, we use water in other ways as well, domestically, cooling towers, et cetera. What can you help us with? And so we came up with Water Compass. So Water Compass is a solution delivered in 3 pieces. There's a hardware monitoring component where a device, a sensor, either attaches to a water meter or adheres to a pipe and uses ultrasound to capture data flow using sound waves. That data is collected and then batched up to a cloud-based application called watercompass.net. And then that analytic dashboard gives users the ability to do analytics, to slice and dice, to drill in to water used at a site or into a meter. And then in the case of cooling towers, track the efficiency of towers. Well, we've built a compelling website for people to use. We don't often see people running to it every day as a course. So we use a customer success specialist to do proactive outreach to our customers and let them know when we're monitoring their service and sites and we see things that are anomalous. Water being used when it shouldn't be, or why is the makeup line on a continuous fill where it's not really cycling? These are evidences of leaks and things that might, be remedied with someone paying attention to that. If they didn't know, they couldn't fix it. So we use our human services as well as the machine learning and the technology services to provide alert and alarm data. And then we write reports on a daily, weekly, monthly, quarterly, annual basis to help people see the efficiency of what we're doing for them. So the devices, we have an FM200, which attaches to a water agency meter. LADWP has validated that these devices do not in any way adversely affect their ability to read their meters and collect information for the purpose of billing. We engaged in a study at LAUSD with LADWP as part of that, and we're very successful there. Our FM300 is a way of introducing a new metering point where you might not have an existing water meter. And so by using ultrasound and clamping onto a pipe, we're able to provide that same data. But both systems use our own 4G LTE communications to throw data to the cloud. And then that cloud is then able to be accessed through a user ID and password. We also have an open API where people could take data out of our cloud into whatever building management system or other systems they choose to grab data from. So the power of the analytics, will give a customer a view into her water use by month, or if you clicked into a month, by day of month, or if you clicked into a day, by hour of day. And so when you stand back and think about that, you're getting a 24-hour hourly snapshot of water used, whereas when you get a water bill every 6 weeks, it's a lump sum. So we give you the ability to get on top of anomalous use, leaks, comparative performance analytics, and other things that are important to managing the resource. We also can give you a view at, say, 3 a.m. Now on a domestic meter where there's water being managed in an office building and everyone's gone home at 3 in the morning, why are we seeing large use cases of water? I mean, why is there continuous use? Those are the kind of things Water Compass can help highlight and illustrate. We're able to get water signatures in place, to help customers refine, what am I looking for? If it's a leak, what's the profile of the leak? Is it a running toilet? What is it? So the typical, ways customers get value here is, tracking what suddenly becomes high hourly use. And in the case of a cracked pipe with water under pressure, that might be continuously high hourly use because the leak's getting bigger. Or moreover, continuous use. So in the case of an office environment, you can see that when people come to work, the usage starts to rise, and if they go home, it starts to fall. But why does it never go to zero? This is a great way of also looking at a makeup meter, and if it's continuously moving, if there is no resting point for the meter on a 24-hour basis, there may be a stuck valve. We provide very comprehensive data on a per meter basis. Here's an example of weekly reports that would show a customer, how am I doing this week versus last week? How does this week compare with my last 4 weeks? And I compare 2 meters side by side. If you go to the next slide, there's a monthly report that shows you how you're doing per month, or a quarterly report that kind of gives you an aggregate of where you are. Which are my biggest using meters? In the case of cooling towers, which makeup meters are using the most water? If you had 10 towers and you were looking at this report and you saw 2 of them with very large makeup metered readings, you might want to investigate that. So in cooling systems, the improved efficiency for tower managers, if you have separately metered makeup and blowdown, we're able to calculate cycles of concentration and display that on our dashboard. And then tracking tower efficiency, certainly within itself over history, but in comparison to other towers under management, gives someone a real good insight into, if I'm using chemical process to cool and to scale and to treat, my airborne pathogens, why is tower 1 operating at a 3-to-1 and tower 15 is operating at a 17-to-1? Why am I not reusing my chemicals as efficiently as I could be on the 3-to-1 tower? And more importantly, then, if there's really a hard water condition with all the gunk inside those tubes that Mike was sharing, maybe I need a front-end process treatment to polish that water so I don't have to use as many chemicals, or maybe I can eliminate chemicals altogether. So Water Compass can really be used as a front-end tool to helping companies like Mike's decide where we should focus our sales energy, because we've clearly got a case where we've got a tower operator that's either being oversold chemicals or he's got an inefficient use of chemical based on his water quality. So the other benefit of Water Compass tracking this makeup and blowdown business is if there are, not deductive meters attached to blowdown and you're paying a sewer charge for every single dollar of water read by the makeup meter, that most of your water, at least half of your water maybe, is evaporating in that cooling process. Why are you paying sewer on 100% of that? So it's a great way of capturing data about how to have a conversation about mitigating sewer charges on blowdown. So these are the kinds of graphs and reports that we give customers. I won't belabor this. This will be on the deck for people to see, but it captures incidents that we escalate to people for attention. An example, in a metropolitan high-rise in LA for a multifamily community, we were called in to help them determine why their water use per occupied unit was so much different than all of the other apartment complexes in their portfolio. We installed on an irrigation meter and on a domestic meter, quickly verified that they were in fact, experiencing leaks. Through a process of investigation, we directed them to their pool room. Their initial reaction was pushback, saying we have the pool being filled by the irrigation line, but our leak problem is on domestic. And we kept guiding them back to the pool room. And what we found upon forensic investigation was a valve had been left in an on position that was filling a fountain outside the building. And the minute we shut that valve off, the dashboard reflected the change in volume. We wound up saving them $185,000 a year, basically returning profitability to that property. More importantly, we saved them 3.4 million gallons of water that was simply waste, potable drinking water waste. No one likes to waste. And, this is a situation where they didn't know, by just looking at their water bills year to year when they budgeted utility expenses, what the baselines really were. And so just because you have a baseline and you've tracked it from last year to this year doesn't mean your baseline is truly reflective of efficient use. Your baseline could contain inefficient use, and that's our role to help you figure that out. This is another partnership with LABBC. This time we worked in the police stations where DWP had alerted the police departments that they had excessive water use for their account. They were in, penalty tiers essentially. We were brought in, and the water's used inside the police changing rooms and your restrooms and the jail, et cetera. But they also operate car washes outside on the back parking lots, for police cars, ambulances, even fire trucks sometimes. And so we separately plumbed in meters to separately monitor the amount of water being used on the car wash applications. And almost immediately we found over 16 sites, 23 cases that we opened over a 12-month period. Some of them stuck floating devices, some a valve connector to soap dispensers connected. One, we had a recycled water line that was just running water into a drain 24/7. No one could hear it. A pipe leak. And so when you go to the next slide and you kind of stand back and look at the results, when we began with them, they were using 1.2 million gallons across that site. And by the end of a year, working with them and working through these leak scenarios, we cut that to 312,000 gallons, and they're washing the same number of cars. So data, it matters. If you're not measuring it, you're not managing it. And our goal is to give the right data to the right person at the right time to help them make use of this precious resource.
Thanks, Ben. Really interesting. I see how all of these technologies can work together, metering, blow down and makeup, identifying where the opportunity is to bring in the technologies for pre-treatment or better, some other upgraded water treatment, and then being able to monitor your use of our time. And I'd be interested when we do in the Q&A to hear more from the entire group on how these technologies can work together. Just a couple updates on LADWP and MWD. LADWP recently increased their technical assistant program incentive. It's the customized performance-based incentive from $1.60 to $2.50 per 1,000 gallons saved over a 5-year period. You can apply at ladwp.com, and we'll put the link into the chat function as well. Metropolitan Water District offers a similar program through their water savings incentive program, where they offer 60 cents per 1,000 gallons saved as well. So you're getting nearly $3.10 and could significantly offset the cost. And currently MWD is also recommending doubling their incentive for conductivity and pH controllers. So we'll keep you up to date to that and some of our information that we push out. And LADWP also is implementing an assessment program. They're launching a program to evaluate cooling tower project opportunities. Participation's super easy. You're just going to complete a few questions on a survey, and you'll sign up, and they'll send their vendor out to conduct an assessment of your cooling tower and also do a quick review at other water saving opportunities at the property. So again, the link will be in the chat function. And now I just want to bring the group back to do a little bit of Q&A. And I'd like to start with Ben and build with Dynamic. How do you think that your technology can work with the actual water treatment upgrades, be it dynamic water or some other water softening type of upgrade?
If you put water compass on the makeup meters and the blowdown meters of the tower in its current state and start driving baselines for how you're performing, when you make a change away from chemical to electromagnetic treatment, you're going to see a measured change. And using our dashboards, that change will become, visible almost immediately as you begin deploying those things. So the tower you're still tracking cycles of concentration, you're still tracking water use, you're still tracking blowdown, but suddenly those numbers change dramatically, and you'll see them as graphic representations through our water compass tool.
Great. Mike, do you see a lot of your customers actually measuring performance?
We see most of our customers having a lack of understanding or a lack of measurement. There's very few that have implemented active functional water meters. Janco, you want to?
Yeah, specifically on the water balance around cooling towers, you have to be familiar and acquainted with what a cooling tower consists of, what consumes the water and what consumes the energy. And I think this is where someone like Ben comes into play, is to help educate clients and to say, listen, to really understand the water balance around your cooling tower, this is the parameters that we have to start to measure. So in terms of the DWT, the DSR technology itself, something you should keep in mind is that it doesn't change the infrastructure or the actual design integrity of the cooling systems itself. It just replaces the way you treat water. So it's an alternative water treatment system. So it's honestly very low-hanging fruits in saving water. So you just remove the chemicals, you plug in electrochemical, but everything around it, the way you measure that in terms of energy and water and all those infrastructures stays exactly the same.
And it's actually even better. We optimize the system. So we're actually running more efficiently at higher cycles. So we're giving better heat transfer at a much higher water utilization.
Yeah, but you still measure of the same measuring points.
Yeah.
And this is where Ben mentioned that the figure starts to change. And
Yeah.
this change in figures is something that we monitor to then just justify the equipment based on the water chemicals and the maintenance savings.
We've also been very realistic, Maureen, that people need to have something that is easy to implement. You know, I mean, yes, change is hard. We want to be as easy to implement on a process change as possible.
Yeah.
So
Water compass is non-intrusive, meaning you don't have to cut into the makeup line. We're basically just attaching something smart to the existing meter. It's about a 2-hour process to make sure enough water runs through that in order to get our calibration readings, and then you're off to the races. Now, if you don't have a blowdown meter in place, there is a need to cut one in, and then we'd attach a water compass device to it, and then be able to give you those separate readings. But it's, again, pretty straightforward to get busy on it right away.
Yeah, so one thing that's worth mentioning is in terms of blowdown, the big key performance indicators is that we reduce that blowdown up to 90%, in some cases up to 100%. It has happened. And if you refer back to the comment you made that the LA City cooling tower base uses about 6 billion gallons of water in terms of makeup, with our technology, you can easily save between 1.5 to 2 billion gallons of water in terms of discharge, just by simply swapping out your chemical dosing system with this alternative water treatment.
Yeah, that's based on the average cycle rate of the towers in the LA basin.
And if you do that, you don't have to change anything in terms of your design.
Guys, this is a very thorough answer. Thank you. I want to also kick it over to Sean, because it may be typical that a lot of clients don't always monitor or install a Hydropoint type of solution up front. I think we're hearing some real best practices coming out here. I'm writing down. But Sean, you guys did pay attention. I mean, it was a substantial project, of course. You wanted to see how it went. So I wanted to go back. You had a slide that talked about, as you're monitoring things, kind of dialing things in and the learning. I wanted to just kind of go back to that and pick up on that piece and the importance of maintenance and engagement, through data.
Yeah, well, you bring up a great point. And while my department is facilities planning, design and construction, we're not facilities maintenance. And so ultimately, our facilities maintenance and plant operations team are the ones who are running these and maintaining them. And, we work closely with them and we do a lot of monitoring ourselves. That being said, I think it could be more substantial to the point of having the dashboards that were described and really doing more monitoring, because, while we ran into that issue once, which was all of a sudden we saw a spike, but it went on for several weeks before we figured out, oh my gosh, like some of these filters needed to be replaced. And so it became more of like training as well, and then trying to leverage the tools a little bit better. But it does become both a resource, a technology, sensor driven strategy, but ultimately, you need the people to maintain it and be trained for it and to monitor the systems. So we're kind of now taking more of a belt and suspenders strategy where we're doing a little bit of monitoring and also working with our plant ops guys to say like, hey, when we see something, like, guys, something's up, can you go check on it? So, the technologies that both Mike, Janco, and Ben are talking about are key, really, in terms of, creating a higher efficiency system, but then also avoiding the waste when issues do happen. So,
I wonder, just hypothetically, what would have been the ROI, had you had that information sooner, like Ben's given out hourly data instead of a couple of weeks, what would that have been? Kind of to how these things work together.
We don't measure in acre feet, but if we're talking about 100,000 gallons a day for 3 weeks, that's a lot. That's a lot of water that was wasted, and just diverted to the sewer system. So
great. I see some other questions coming in. There's a question, I think a good rule of thumb question too, really kind of what's the minimum size of tower kind of that makes it worth it to kind of look into these types of advanced treatment or metering
You know,
options?
I'll grab that one. We've
Okay.
worked extensively to get our costs down. We've actually gone down about 40% in our costs from 2 years ago to today.
Oh, wow.
And groups like SoCal Gas and LA City, they have a wide profile or portfolio and huge buildings and small buildings. And so what we found is certain clients, especially like SoCal Gas, has us going down all the way to 80-ton towers. NASA, I just looked at a system that was, I think, a 50-ton tower, and largely because they have multiple applications and they just don't want to have to handle the chemicals. They want to maximize the process. And so I would say, you know, honestly, I would target the buildings in the 20,000 square foot and greater, and depending on the heat load. But again, every tower could have a benefit. It just depends on what the goals of the client is.
Sure.
And Mike, what about the local water quality? How does that factor into the decision?
Huge. Yeah. So, in the Southwest, especially, the hardness of the water is quite high. And that's something that someone commented about electromagnetic, and I like to draw the distinction. We're electrochemical. So we're actually generating biocide. We're generating things that kill pathogens that actually do a better job at sanitization of water than traditional chemicals. But the water hardness is also a major factor, and that's what the DOE actually reported. Anywhere where you have water hardness issues, you have scaling problems, you have the equipment life being reduced. We can actually extend equipment life. We can mitigate that scale forming challenge that people have.
So we're talking about, first metering your blow down, understanding your size of your system and your local water quality. And I think when LADWP does their cooling tower assessments, they look at all of those things and can definitely help provide customers with direction on where they should go, the first steps of better cooling tower management.
I would like to just say I really appreciate LADWP and Metropolitan Water District for having incentives for putting things. I've always advocated. I hate penalties, and that's unfortunately what we may end up getting to, is where people are going to start getting penalized for water waste. I love it when incentives come out. The Southern Nevada Water District now has a $15 per 1,000 gallon rebate, which is incredible. That justified a $350,000 project, got us under a 2-year ROI for Americold. But you guys at Metropolitan Water District and LADWP have been after this for a long time, and those incentives make a huge difference in getting people to really take a look at this stuff.
Mo, I was having an audio issue, and sorry if you covered it, but with the increased incentive, back of the envelope, how do you think that impacts the ROI of some of these projects?
I mean, it definitely is going to be different depending upon the technology that you use. But you're going to bring it down to probably 2 years for a lot of them, which is well within
the magic number.
Magic number, yeah. Especially when you go through both programs. And the one thing that I would ask Ben is, Ben, what about the ROI for something like monitoring and leak detection? How do your customers evaluate ROI when a leak may vary, hugely?
Yeah, and so there's a number of questions we can ask a client about their current water use and how they're tracking things. One of them is, have you made any insurance claims that have been water related? What was the deductible? Was there any increase in your premium or increase in your deductible as a result of that? Was there any lost use of the facility, as a result of remediating that water damage? That starts getting people to think about, well, it's not just about my water spend, but it's more importantly about how mismanaged water is costing me more than I think. We also have, calculators that can, based on use cases, talk about an average toilet. How many toilets do you have? What percent of toilets develop leaks over time? What's the size of that leak? Is it possible you've got a leaking toilet in your 350 unit apartment complex? No, really? There's not possible a leak anywhere in there? DWP would argue that they've managed toilet replacement programs for decades to move leaking toilets out of buildings. So there's definitely use cases where fixtures themselves are just known to leak. And I think people get their mind around this fairly quickly. Some even think of it as insurance, where I don't have a leak today, but I know what a leak cost me last time, and I don't want one again because I don't want to either increase my premiums by making another claim. So there's lots of ways for us to have that conversation with the client to help them pay this back. But the candid conversation is, within 30 days of installing, we find something on almost every meter that we install on.
Great. Well, I want to thank everybody and also be cognizant of time. We are at time, so thank you all. I'm sorry we weren't able to get to all of the questions that were coming in. We will get back to you. I'll direct those to the presenters and get back to you in writing. I think we have a couple of closing slides here. Some key takeaways. Drinking water should be for drinking. We are in a desert. Let's be aware of that. Not to live in scarcity, but let's be smart. Let's not waste. We don't want to waste. Just because it's cheap doesn't mean we should abuse it, right? Let's learn, from what examples that we see and try not to drive that here. Next, please. Yeah, it got in here. So I think this one, captures it well. Let's not think of this as a negative thing. This is an opportunity for us to evolve and do things smarter, right? And be more considerate of others and win together, right? So thank you all for joining, guys, and a ton of great resources coming through. Please reach out. As Mo mentioned, DWP's running assessments. We're here to help connect the dots as we have on the projects that you heard highlighted here. So hit us up. Thank you, everybody, and hope to see you all next month. Thanks again, you guys, for making the time.